Hello everyone. In this video we are going to see about CoAP protocol and how it's used in IoT devices. CoAP is an IoT protocol that has interesting features specifically designed for constrained devices. Constrained devices in the sense these devices are having very extreme resource constraints, that means limited energy supply, small battery power and limited memory space like little flash memory and very little RAM memory and very small computing capabilities. These devices are called constrained devices, and these constrained devices can constitute a network which is known as constrained networks. This CoAP protocol is mainly designed for constrained nodes and constrained networks and in the application of IoT. Okay, so this protocol is defined as per the specifications given by RFC 7252. This protocol is designed for machine-to-machine applications such as smart energy and building automation. Smart energy. It is the process of using devices for energy efficiency. Building automation. Here, the various components within a building structure such as heating, ventilation, air conditioning, and electrical, lighting, shading, access control, security systems, or some other interrelated systems within a building structure. Okay, so these can be controlled by using this application. So the primary goal of this type of infrastructure is to improve system efficiency, reduce cost and increase safety. Coming to IoT, IoT is one of the most interesting and promising technology trends. It is an ecosystem where objects, people, devices are interconnected and exchange data. Features of CoAP protocol. It is a web protocol used in machine-to-machine applications with constrained requirements, and asynchronous message exchange will be supported by this protocol, and low overhead and very simple to pass. Coding and encoding are very simple. URI and content type support is possible, and proxy, it can access a gateway between the endpoints, and the caching capabilities, that means the temporary storage capabilities, are very interesting in CoAP protocol. CoAP can be represented as, see this diagram, application layer and user description protocol layer. In between this CoAP protocol will be having two layers, request and response layer and messages layer. See the two different layers. See, in the message layer, it deals with UDP and with asynchronous messages. And in request response layer, it manages request response interaction based on request response messages. CoAP supports 4 different message types. These are the 4 message types: confirmable, non-confirmable, acknowledgement and reset. Before going deeper into the CoAP protocol, we should be aware of some important terms. These are the important terms. First of all, endpoint, an entity that participates in the CoAP protocol. Usually, it is identified with the host. Then sender, the entity that sends a message, and the recipient, the destination of a message. And client, the entity that sends a request and the destination of the response. Okay, see, client is the destination who receives the response back, so it is called as the destination of the response. Then server, the entity that receives a request from a client and sends back a response to client. CoAP message model. See, this is the lowest layer of CoAP and it deals with UDP exchanging messages between endpoints. Each CoAP message has a unique ID. This unique ID is very useful to detect duplicate messages. And these are the basic parts in a CoAP message. What are the three basic parts? A binary header, a compact options and payload. These 3 parts are involved in a CoAP message. As I said earlier, these are the two main messages used by CoAP protocol. First of all, confirmable message. Confirmable message is a reliable message. When exchanging messages between two endpoints, these messages can be reliable. In CoAP, a reliable message is obtained by using confirmable message, which is represented like CON. Using this kind of message, the client can be very sure that the message will arrive at the server side. A confirmable message is sent again and again until the other party sends an acknowledgement message. The acknowledgement message contains the same ID of the confirmable message. See this picture. Client is sending a confirmable message to a server and server is responding with the acknowledgement message to client, and both message IDs are same. See the ID numbers, both are same. If the server has troubles in managing the incoming request, it can send back a REST message, that is represented as RST, instead of the acknowledgement message. Anyhow, for a confirmable message which is sent from the server, which is sent from the client, the server has to definitely respond back. Okay, either with acknowledgement message or with the REST message, RST message. It has to respond back to the client. Then non-confirmable message. These are unreliable messages and it doesn't require an acknowledgement by the server, and it does not contain any critical information that it must be delivered to the server. Okay, even if these messages are unreliable, they have a unique ID. Okay, so even unreliable messages are having unique ID.